In this lesson, we'll break down some terminologies of organic chemistry. Terminologies refers to key words that might be frequently used by a set of discipline. In organic chemistry, we also have English words that may have different meanings in chemistry. The first, homologous series. This is a group, or family of compounds, that have the same functional group, can be derived from a general molecular formula, and each successful member differs from one another by a CH2 unit, or 14, by relative molecular mass. There are several of them. We will hold on to a few, like alkanes, alkenes, alkynes. They are the hydrocarbons. They consist of hydrogen and carbon only. Other homologous series are alkanol, alkanal, alkanon, alkanoic acid, amines, and amides. They are all ternary organic compounds, consisting of carbon, hydrogen, and any other atoms, like oxygen, nitrogen, and so on. How do we identify homologous series? Their characteristics. Characteristics of a homologous series in organic chemistry include 1. Same general formula. All members of a homologous series share the same general molecular formula. For example, alkanes follow the formula CnH2n+2. Methane consists of one carbon atom per molecule. This means N is equal to 1. We have 1 times 1 for carbon but 2 times 1 plus 2 for hydrogen. We have CH4. Try when N is 2 to 4, you will have C2, H6 for ethane, C3, H8 for propane, C4, H10 for butane. They all follow the formula. Alkanol follows Cn, H2n+1, OH. Do the same with that of alkanols when N are 2 to 4. We will have ethanol, N-propanol, and N-butanol too. Graduation in physical properties. Members show a gradual increase in boiling point, melting point, and density, as the molecular mass increases. But gradual decrease in solubility as molecular mass increases, or addition of methylene group, CH2, a water, or hydrophobic group. Since the CH bond, that is the carbon to hydrogen bond, is more of a nonpolar group. This decreases the solubility of the organic compound. The melting point of methanoic acid is 100 degrees, ethanoic acids is 118 degrees. The increase in boiling point is as a result of the increase in van der Waals forces, which is as a result of an increase in molecular size. This shows that, the more the molecular mass, the higher the boiling point. 3. Similar chemical properties. All compounds in a series have similar chemical properties because they contain the same functional group. Similar doesn't mean the same. 4. Same functional group. Each member has the same functional group responsible for their characteristics, which might be physical or chemical behavior. For example, alcohol has the OH group, the ol group. Alkanoic acids have COOH group, the carboxylic group. Functional group is the main thing a homologous series has in common, which determine their characteristics. 5. Successive members differ by CH2 unit. Each successive member differs from the next by a methylene group, CH2, which is a difference of 14 in relative molecular mass. Methane is CH4, whose relative molecular mass is 16. Ethane, the successive member in methane homologous series, is C2H6. Its relative molecular mass is 30, 30 minus 16 is 14. 6. Nearly same method of preparation. Compounds in the same homologous series can usually be prepared by similar methods. For instance, decarboxylation of sodium alkanotes using soda lime will form alkanes. Dehydration of alkanols forms alkenes, etc. The second is the chemical formula. Representation of organic molecules. Just like words have different spellings, molecules can be represented in different ways. 1. Molecular formula. This shows the number of atoms present in a compound. Example C2, H2 for ethine, C6, H6 for benzene. 2. Empirical formula. The simplest ratio of different atoms in a compound. Example, CH3 for ethane, which is C2H6. CH for both ethene and benzene. Examiners may ask you to differentiate between molecular and empirical formulas. Remember that the relationship between empirical formula and molecular formula is N times empirical formula is equal to molecular formula. Can you see the connection? It is possible for an empirical formula of a compound to be equal to its molecular formula. Here, it means N is 1. 3. Structural formula. This shows how atoms are arranged in 2D or 3D spaces. Look at some examples. The structural formula is very important in organic chemistry. It helps in distinguishing compounds. It is possible that different compounds may have the same molecular formula but different structural formula, which distinguish them. These phenomenon is called isomerism. 4. Skeletal formula, a simplified representation used by chemists, where carbon atoms are implied at the bends or edges of lines. Hydrogen atoms are ignored here. Double lines means double bond. Triple lines means triple bonds. 5. General formula. This is the formula which other members of the homologous series can be derived from. This is majorly based on the group of the organic compounds having the same number of functional groups. Being able to interpret and compare these representations will help you understand how molecules function in real-world chemistry. If you have not subscribed, please do. Don't forget to share the link. Spread the message as you click the notification bell. Support me with this. The third terminology to look into is functional groups. The superpowers of organic molecules. Functional groups are specific atom arrangements that determine a molecule's properties and reactivity. It can be a bond type, an atom, or group of atoms. Let's explore some important ones. Carboxylic acids, COOH. Responsible for the sour taste in vinegar. Esters, COOR. Used in artificial fragrances and flavorings. Aldehydes or alkanals, CHO, and ketones or alkanon, CO. Found in perfumes and food flavoring. Alcohols, OH. Found in beverages, hand sanitizers, and fuel. Amines, NH2. Essential for proteins and responsible for fishy smells. Halides, X. Found in refrigerants and medicines. Understanding functional groups helps predict a molecule's uses, reactions, and interactions in biological and industrial processes. The fourth is isomerism. Different compounds having the same formula but different properties. Sometimes, molecules with the same formula have different properties due to their arrangement of carbon atoms and their carbon atom position they are attached to. This is called isomerism. There are two main types. 1. Structural isomerism. Here, atoms are arranged differently, affecting boiling points and reactivity. 2. Stereoisomerism. Here, they have the same structure but different 3D structures. They are divided into 1. Geometrical, or, and E and Z isomerisms, or, cis and trans isomerism. Here there is a different spatial arrangement around a double bond resisting rotation. Example, cis but 2-ene versus trans but 2-ene. 2. Optical isomerism. R and S isomerisms or L and D isomerism. Mirror image molecules that rotate light differently, affecting their biological activity. Example, D and L-glucose. Understanding isomerism is crucial in drug development and material science. In our next lesson, we will look into isomerism. Be there.